Yellowstone supervolcano, it's a caldera volcano. Like they didn't realize that it was so big until somewhere in like the 2000s, I think it was. They did satellite imagery and they realized, oh my God, that's the caldera of a volcano. Like this Yellowstone thing. We thought it was just this crazy place with hot springs.
Beneath the captivating surface of Yellowstone National Park, a concerning shift is underway, prompting a recent alert from scientists. The expansive dome-shaped uplift within the park has been gaining size, a topic that caught the attention of renowned podcaster Joe Rogan. Speculation is rife about whether this could signify the awakening of the dormant giant. What is causing the enlargement of this massive growth, and what consequences might follow? Join us as we delve into the implications of the Yellowstone system alert, highlighting the growing size of the dome-shaped uplift. The sleeping giant is awake. Yellowstone National Park is a marvel of nature's beauty found in the American West. However, it also sits atop a ticking geological time bomb, which is the Yellowstone supervolcano. This supervolcano is a huge force of nature with the potential to unleash devastation on a scale that is almost incomprehensible. As fascinating as the history of Yellowstone's volcanic activity is, it is quite as terrifying. The area has witnessed massive eruptions that were unimaginable. According to Joe Rogan, the huge dome-shaped uplift is increasing in size and causing worry to scientists. The Huckleberry Ridge eruption set a foundation for the immense volcanic activity that defines Yellowstone's geologic history. This eruption, one of the largest in the Earth's recent history, formed the initial Yellowstone caldera, a massive volcanic crater that remains a central feature of the park today. Following this huge event, the area witnessed two more significant eruptions: the Mesa Falls eruption, around 1.3 million years ago, and the Lava Creek eruption, approximately 640,000 years ago. Each of these eruptions contributed to the complex volcanic landscape of Yellowstone, shaping the region's topography. Although smaller than the Huckleberry Ridge event, the Mesa Falls eruption was still of outstanding scale. It produced widespread ashfall that covered large areas of the current United States, further transforming the landscape and impacting the environment. The opening formed by this eruption partially overlaps with the earlier Huckleberry Ridge opening, illustrating the ongoing volcanic activity beneath Yellowstone. The most recent of the three, the Mesa Falls eruption, together with the Lava Creek eruption, was responsible for the formation of the present-day Yellowstone caldera, the park's largest and most notable volcanic feature. This eruption was so vast that it ejected a massive volume of volcanic material, with ash reaching as far as the Mississippi River and the Gulf of Mexico. The opening that spans almost the entire width of the park is the aftermath of this eruption. In essence, these eruptions have had huge effects on the global climate, influencing weather patterns and leading to cooler temperatures worldwide. The ash and gases released into the atmosphere during these events would have had a significant impact on the Earth's climate system, likely leading to something called volcanic winters, where the sun's rays were partially blocked, reducing global temperatures. Such climatic disruptions could have affected ecosystems and wildlife, leading to changes in species distribution and possibly contributing to evolutionary pressures on plants and animals. In addition to their climatic impact, these eruptions have played a crucial role in forming the unique geothermal features that define Yellowstone National Park. The constant emptying and refilling of the park's magma chamber have fueled the formation of its renowned geysers, hot springs, and other hydrothermal wonders. The heat driving these features comes from the active magma chamber beneath the park, which is directly linked to the volcanic eruptions that shaped Yellowstone's landscape millions of years ago. In the present day, the testament of these ancient volcano eruptions provides invaluable insights into volcanic processes and the Earth's geologic history. The layers of volcanic rock and ash deposited by these eruptions serve as a geological record, allowing scientists to amass the timeline of volcanic activity in the region. In understanding Yellowstone's past, predicting future volcanic behavior, and assessing the potential risks associated with the park's supervolcano. This record is important. As such, the study of these eruptions and their consequence continues to be a crucial aspect of geological research in Yellowstone. The Sour Creek Dome and the Mallard Lake Dome are at the heart of the volcanic activity occurring in the present day. These domes are not typical volcanic structures. Rather, they are more like giant blisters on the Earth's surface, and they are formed by the upward pressure of magma refilling the opening's magma chamber. To understand the significance of these domes, imagine a giant underground balloon filling up with magma. As this balloon expands, it pushes the ground above it upwards, thereby creating a dome shape. That is basically what is happening beneath the Sour Creek and Mallard Lake areas. These domes are massive, stretching over several kilometers in width and rising hundreds of meters above the opening floor. In recent times, scientists have noticed a strange occurrence happening to these domes. The presence of these resurgent domes is a clear sign that the volcanic system beneath Yellowstone is nothing near dormant. It is an indication that the restless giant is biding its time beneath the park's serene lakes and majestic geysers. As recently announced, the increasing size of the dome-shaped uplift serves as a reminder of the dynamic and potentially dangerous nature of this supervolcano. The Yellowstone supervolcano is a sleeping giant with a history of cataclysmic eruptions that have reshaped the landscape and affected the global climate. The formation of the Yellowstone caldera and the resurgent domes like the Sour Creek Dome and the Mallard Lake Dome are evidence of the ongoing volcanic activity beneath the park. Understanding these geological features is crucial as they offer clues about the behavior of the supervolcano and the potential risks it poses. The claims of increased volcanic activity are not out of the blue. They are backed up by clear, unmistakable factors. Come along to find out what these factors are. Intense signs and warnings from the volcano. However, as a result of a series of unsettling signs pointing towards increased geological activity, Yellowstone National Park has recently been the center of heightened attention. The most notable among these is the significant increase in the size of a dome-shaped uplift within the park. This is a massive alteration in the park's very foundation, suggesting that the forces beneath Yellowstone are stirring. The mysterious shifts in the water levels of Yellowstone Lake are also adding to the concern. Scientists have observed that the lake's water is not as stable as it once seemed. Instead, it has been tilting like a seesaw, indicating something powerful and dynamic is happening beneath the surface. This tilting of the lake is a red flag, signaling changes in the volcanic system underneath. Furthermore, the appearance of long fissures in the ground has led to widespread speculation and concern. These fissures are potential indicators of magma movement beneath the park's surface. The presence of these fissures suggests that the volcanic activity underneath Yellowstone is a very real and present danger. From the growing dome-shaped uplift to the shifting water levels and emerging fissures, the recent observations in Yellowstone are clear indicators of increased volcanic activity. These signs have played a crucial role in raising public awareness about the potential dangers of Yellowstone. Technology has been beyond effective in monitoring these new changes, including the famously used GPS, which stands for Global Positioning System. Scientists keep tracks of subtle ground movements. Yellowstone National Park is a living laboratory where the Earth's inner workings are on full display. The resurgent domes, particularly the Sour Creek Dome and the Mallard Lake Dome, are central to Yellowstone's geological mystery. The importance of these domes extends beyond their physical presence. They are key indicators of the restless nature of the volcanic system underneath Yellowstone. The movement and growth of these domes provide critical clues about the behavior of the magma chamber and the potential for future volcanic activity. Monitoring such a dynamic and complex system requires advanced technology, and scientists have made significant strides in this area. At the forefront of these efforts are modern techniques like Global Positioning System, commonly called GPS, and interferometric synthetic aperture radar. The global positioning system is used to precisely measure ground movements, allowing scientists to track the slightest shifts that could indicate volcanic activity, while interferometric synthetic aperture radar complements this by using radar images from satellites to map ground deformation over large areas. Providing detailed and continuous data that was previously unattainable, these technologies have revolutionized human ability to monitor volcanic activity. Recent scientific findings have shown the importance of this advanced monitoring. The discovery of the increasing size of the dome-shaped uplift is a case in point. This significant change hints at the movement of magma beneath the surface and could signal an increase in volcanic activity. A massive crack that appeared seemingly overnight, the Hidden Falls fissure, has similarly captured the attention of both scientists and the public. These discoveries highlight the dynamic nature of Yellowstone's geology and show the need for ongoing vigilance. The implications of these findings are huge. The advances in monitoring technology have provided humans with unprecedented insights into these processes, allowing scientists to track the park's volcanic activity with remarkable precision. The potential consequences of this eruption cannot be overemphasized. It will not only cut across different sectors of the economy, it will also directly affect lives. Devastating consequences of the Yellowstone eruption. The potential eruption of the Yellowstone supervolcano is a scenario that carries with it catastrophic consequences for the immediate vicinity and potentially for the entire globe. The widespread fallout of volcanic ash would be one of the most immediate effects of such an eruption. This ash, much like fine abrasive sand, would blanket landscapes, smothering everything in its path. This fallout could disrupt transportation networks, burying roads, railways, and airports, and bringing travel to a gridlock. But the impact of ash extends far beyond mere inconvenience. The weight of accumulated ash could cause buildings to collapse, power supplies to be disrupted, and lead to significant structural damage. Furthermore, this ash, loaded with sharp particles, poses a serious threat to respiratory health, capable of causing severe problems if inhaled by humans or animals. The environmental damage would be massive. Ash and volcanic gases can lead to the contamination of water sources, making them unsafe to drink and harming aquatic ecosystems. The sulfur dioxide gas released during the eruption could mix with water vapor in the atmosphere, falling back to Earth as acid rain. This acid rain would devastate ecosystems, acidifying lakes and rivers, damaging plant life, and corroding built structures. Aside from the environmental impact, a Yellowstone eruption could usher in a volcanic winter. The massive amounts of ash and gases ejected into the atmosphere would form a dense cloud, blocking sunlight and leading to a significant drop in global temperatures. This sudden cooling could have dire consequences for agriculture, leading to widespread crop failures and food shortages. In a world heavily reliant on stable agricultural outputs, this could result in a global food crisis, with shortages leading to increased prices and potential famine in more vulnerable regions. The societal impacts of such an eruption would be groundbreaking. Infrastructure damage from ash fallout and seismic activity could disrupt essential services, from healthcare to the supply of electricity and water. The health hazards posed by ash and volcanic gases could lead to increased strain on medical services, with respiratory issues and other health problems becoming more prevalent. Joe Rogan has an interesting view about the recent incident in Yellowstone. What comment does the commentator pass this time around? Let's see. Joe Rogan's unfiltered views about Yellowstone's supervolcano. Joe Rogan, a renowned commentator and podcaster, has a flair for delving into complex issues and bringing them to the forefront of public discussion. His discussions on the Yellowstone supervolcano are no exception. Capturing the attention of his vast audience and amplifying the conversation around this geological giant, Rogan has raised strong warnings about the potential dangers hidden beneath the serene landscapes of Yellowstone National Park. He also highlighted the sheer power of the supervolcano and the massive impact its eruption could have on the surrounding region and, potentially, on a global scale. Through his platform, the podcaster has succeeded in painting a vivid picture of the supervolcano's might, drawing from the well of scientific findings to underscore the seriousness of the situation. Its intersection with scientific findings is one of the key aspects of Rogan's commentary. Although he is not a scientist, he often references the latest research and expert opinions to inform his discussions, translating complex geological phenomena into terms that are easy to understand and engaging to his audience. This approach has allowed him to bridge the gap between the scientific community and the general public. Rogan's discussions about the recent unsettling signs at Yellowstone, such as the increasing size of the dome-shaped uplift and the appearance of fissures, echo the concerns raised by scientists. Scientists deserve their flowers for working tirelessly to monitor, research, and prepare for the eruption of volcanic systems. Scientists utilize modern and high-tech equipments. Crucial for deciphering the subtleties of this massive volcanic system is the task of keeping a vigilant eye on the Yellowstone supervolcano, which involves a complex network of monitoring efforts. Employing a range of advanced technologies to track any changes that might indicate shifts in volcanic activity, scientists and researchers are engaged in continuous observation, providing invaluable data that inform both the scientific community and the public. This diligent work is foundational in understanding the supervolcano's behavior. Cutting-edge tools like GPS and INSAR are central to these monitoring efforts.
Beyond mere observation, scientific research plays a pivotal role in disaster preparedness. Understanding the supervolcano's complex mechanisms allows researchers to develop potential strategies for mitigating the impacts of a possible eruption. This research is about predicting when an eruption might occur and about understanding how such an event would unfold and the best ways to protect lives and infrastructure. For instance, the study of past eruptions and the behavior of resurgent domes within the opening provides insights into the supervolcano's eruptive history and potential future activity. This knowledge is instrumental in developing evacuation plans, designing infrastructure that can withstand volcanic events, and implementing early warning systems to alert the public promptly. Moreover, the ongoing research contributes to the broader field of volcanology, enhancing our understanding of volcanic processes and their impacts on the environment and human society. This body of knowledge is crucial for informing policy decisions, emergency response strategies, and public education campaigns aimed at increasing awareness and preparedness among communities at risk. The monitoring and research efforts centered around the Yellowstone supervolcano are vital components of a broader strategy aimed at safeguarding lives and minimizing the potential damage from volcanic events. We can better equip ourselves to face the challenges posed by one of nature's most formidable forces through continuous observation, detailed scientific research, and the development of preparedness strategies. Yellowstone is an arena of numerous natural phenomena that serve as tourist attractions. It is a place of immense marvel. Yellowstone's beautiful and scenic marvels. Yellowstone National Park is not just home to the ominous supervolcano lurking beneath its surface. Showcasing the Earth's dynamic processes, this park has many natural phenomena, each more fascinating than the last. From the geothermal wonders to the rich biodiversity, Yellowstone offers a unique glimpse into the natural world's complexity and beauty. The park stands atop one of the world's largest active volcanic systems, and this geologic hotspot fuels a variety of geothermal features unrivaled anywhere else in the world. The park boasts over 10,000 hydrothermal sites, including more than 500 geysers. The most famous geyser, Old Faithful, is evidence of the park's volatile underbelly, shooting boiling water up to 180 feet into the air at regular intervals. But Old Faithful is just the tip of the iceberg. The park is dotted with colorful hot springs, mud pots, and fumaroles, each contributing to the eerie beauty of this volcanic wonderland. Known for its striking colors ranging from blue to orange, the Grand Prismatic Spring is the largest hot spring in the United States and a visual spectacle resulting from microbial mats around its edges. That's not all, however. Another breathtaking feature, the Grand Canyon of Yellowstone, showcases the park's dramatic geological history. Carved by the Yellowstone River over thousands of years, this canyon stretches approximately 24 miles long, up to 1,200 feet deep, and more than 4,000 feet wide in places. The canyon's walls display a mosaic of colors due to the hydrothermal alterations of the rhyolite rock. The lower and upper Yellowstone Falls add to the canyon's majesty, creating spectacular waterfalls that plunge into the Yellowstone River, further sculpting the landscape. Yellowstone's natural phenomena extend beyond its geothermal and geological features. The park is a sanctuary for a wide range of wildlife, making it one of the last natural ecosystems in the northern temperate zone. It is home to large free-roaming herds of bison, often considered a symbol of the American West. Visitors might also spot elk, grizzly bears, wolves, and bald eagles, each playing a crucial role in the park's ecological balance. This rich biodiversity offers invaluable insights into conservation, the interdependence of species, and the complexities of natural habitats. The park's flora is as diverse as its fauna, with over 1,700 species of trees, shrubs, and wildflowers painting the landscape in a mosaic of greens, yellows, and purples. The vast expanses of lodgepole pine forests, interspersed with aspen, spruce, and fir, provide a contrast to the park's geothermal areas. These forests not only offer a habitat for wildlife, but also play a significant role in the park's ecological processes, including fire regeneration cycles that mold the landscape. Clearing old growth and making way for new life, natural forest fires are a critical aspect of Yellowstone's ecology. The 1988 fires, one of the largest in the park's history, transformed over a third of Yellowstone. It was initially perceived as a catastrophe, but there was a silver lining behind the clouds. Eventually, as the consequence revealed the resilience and adaptability of nature, with new growth flourishing in the burned areas, demonstrating the role of fire in ecological succession and forest renewal. Volcanic eruptions are among the most powerful natural events on Earth, with the ability to reshape landscapes, affect global climates, and dramatically impact human and ecological systems. Throughout history, several eruptions around the world have demonstrated the immense force and extensive consequences of volcanic activity. People wonder if there have been real-life instances of volcanic eruptions and their devastating consequences. Let's take a look at such instances. The history of harsh volcanic eruptions. In 1815, the eruption of Mount Tambora occurred, and to date, it stands as one of the most powerful eruptions in recorded history. The explosion was so huge that it ejected approximately 100 cubic kilometers of magma, ash, and volcanic gases into the atmosphere, creating a global climatic phenomenon known as the year without a summer. It also had huge socioeconomic effects that rippled across the globe. The ash and sulfur dioxide that were thrust into the stratosphere reflected sunlight away from the Earth, leading to abnormal weather patterns that persisted for years. In Europe, the summer of 1816 was marked by incessant rain that caused devastating floods, ruining crops and leading to one of the worst famines of the 19th century. In North America, particularly in the northeastern United States and eastern Canada, snow fell in June, and frost was recorded in July, decimating harvests and exacerbating food shortages. However, the effects of the eruption were not limited to the northern hemisphere. In the tropics, the monsoon cycle was disrupted, leading to abnormal rainfall patterns that contributed to outbreaks of cholera in India and famine in China. The global temperature anomalies induced by the eruption also affected ecosystems, leading to the migration of species to new areas and the disruption of natural predator-prey relationships. Culturally, the dramatic climate changes inspired notable art and literature. For example, the gloomy, cold summer of 1816 is believed to have influenced Mary Shelley's creation of Frankenstein and Lord Byron's Darkness, both of which reflect the period's despair and gloom. Moreover, the Tambora eruption serves as a critical case study for for understanding the potential impacts of volcanic-induced climate change. It provides valuable insights into the short-term climatic consequences of large-scale volcanic eruptions, helping scientists to refine models that predict the Earth's climate response to aerosol injections into the atmosphere, whether from volcanic activity or hypothetical geoengineering efforts. Another instance is the eruption of Krakatoa, which took place in 1883. It had immediate catastrophic impacts and also left a lasting imprint on the world in several unexpected ways. The sheer force of the eruption was equivalent to 200 megatons of trinitrotoluene, commonly called TNT, which is about 13,000 times the nuclear yield of the bomb dropped on Hiroshima. The sound of the explosion was so loud that it was recorded as the farthest traveled sound in history, heard as far away as the island of Rodriguez near Mauritius, approximately 4,800 kilometers away. The tsunamis generated by the eruption were equally unparalleled, with waves reaching heights of up to 40 meters, erasing coastal villages and towns. The sea waves traveled across the Indian Ocean, affecting shores as far away as South Africa. With most casualties resulting from these tsunamis, the human toll was staggering. The atmospheric effects of the Krakatoa eruption were also huge and long-lasting. The ash and sulfur dioxide propelled into the stratosphere spread around the globe, creating a veil that dimmed sunlight and produced clear red and orange sunsets, famously captured in Edvard Munch's painting, The Scream. This global atmospheric phenomenon, known as volcanic winter, led to lower temperatures worldwide, with an estimated decrease of 1.2 degrees Celsius. The following year, 1884, saw unseasonably cold weather, crop failures, and food shortages in many parts of the world, demonstrating the broad climatic impacts of significant volcanic eruptions. The Krakatoa eruption also marked a significant moment in the field of volcanology and the study of atmospheric sciences. It was one of the first major eruptions to be systematically studied from a scientific perspective, leading to the establishment of the Volcanological Survey of Indonesia. The global dispersion of ash and the atmospheric effects were meticulously recorded, providing valuable data that contributed to the development of modern climatology. The eruption emphasized the importance of global telecommunication networks, as it was among the first worldwide news events to be rapidly communicated across the telegraph network, highlighting the interconnectedness of the world in the face of natural disasters. The 1980 eruption of Mount St. Helens was a multifaceted disaster that extended well beyond the immediate explosive event. The blast was followed by a massive pyroclastic flow, a high-speed avalanche of hot ash, volcanic gas, and debris, which scorched and flattened everything in its path for miles. This flow was accompanied by volcanic mudflows that buried river valleys and damaged bridges, roads, and buildings, complicating rescue and recovery efforts. In addition to the human tragedy and infrastructural damage, the ecological consequences of the eruption were huge. Approximately 230 square miles of forest were devastated, transforming lush woodland into a barren wasteland. The intense heat from the eruption and the subsequent pyroclastic flows sterilized the soil, initially making the area seem lifeless. However, this destruction set the stage for an extensive natural experiment in ecological succession. In the years following the eruption, scientists closely monitored the gradual return of plant and animal life to the blast zone, providing invaluable insights into how ecosystems recover from catastrophic disturbances. The eruption also led to significant advancements in volcanic monitoring and emergency preparedness. Before the 1980 eruption, Mount St. Helens had been dormant for 123 years, and its reawakening highlighted the need for better predictive capabilities. In response, the United States Geological Survey intensified its monitoring of the nation's volcanoes, particularly those in the Cascade Range, employing new technologies and methodologies to detect signs of volcanic activity early. One of the most critical lessons learned from Mount St. Helens was the importance of paying attention to warning signs. In the months leading up to the eruption, the mountain exhibited several precursors, including earthquakes, steam explosions, and the growth of a massive bulge on its north flank. These signs prompted the authorities to establish a red zone around the volcano, a decision that, despite the challenges in enforcing evacuations and restricting access to the area, undoubtedly saved lives. The Mount St. Helens eruption remains a pivotal moment in the study of volcanology and disaster management. It showed the unpredictable nature of volcanic eruptions and the need for vigilance and preparedness in volcanic regions. The event's comprehensive documentation and the wealth of scientific data gathered have continued to inform volcanic hazard assessments and emergency response strategies in the United States and around the world, ensuring that the lessons learned from Mount St. Helens continue to resonate in the field of natural disaster management. Although relatively small in terms of volcanic output, the eruption of Eyjafjallajökull in Iceland in 2010 had a disproportionate impact on human activities due to the extensive air travel disruption it caused across Europe. The ash cloud generated by the eruption led to the largest air traffic shutdown since World War I, affecting millions of travelers and causing billions of dollars in economic losses. This event showed the potential for even minor eruptions to have significant societal impacts in our interconnected world. Thanks for watching. Let us know what you think by leaving a comment. Kindly like and subscribe for more intriguing videos.